All right, we're going to do everyone's favorite thing, word problems, application, kind of tying it a little bit into the graph, but some of this is a little bit review as well. So you've seen equations like this before. Talks about a diver's height. Whoops, I got to fix this. This should say, let me fix this right now. That, of course, should say plus. Okay. Diver's height can be represented by this equation, h equals negative 16t squared plus 16t plus 40, where h is the diver's height in feet after t seconds. Determine and interpret the meaning of the y-intercept. Now remember, I'm going to go kind of fast here, but we'll have a live Zoom lesson, as we always do, so please check that out. Okay, the y-intercept, remember, all y-intercepts have an x value of 0. So if I plug 0 in for t, these two things here in front go away, and I'm just left with the 40. So the y-intercept is 40. Now what does it mean in the context of this problem? Remember, when I plug in 0 for t, we got h equals 40. So that means that is the starting height of the diver at time 0. In other words, before the diver did anything, they're standing, this is the starting height. They're standing on a platform or a board or whatever that's 40 feet above the water. Okay? Springboard, whatever it is. Remember, y-intercept is always when x is 0. So here you think about time 0, they're at 40 feet high. Now find the maximum height attained by the diver. Now I'm hoping you realize, so, let's say a diver's, I'm going to make a rough sketch over here, okay? Let's say they're on some platform here and the water's down here. Now the diver, especially on a springboard, they don't just kind of go straight down, they first jump up. So the diver follows parabolic motion like that, okay? So what's special about, where does the high point occur? I hope you realize the high point's right here, and we know that we call that thing the vertex, right? This is a parabola, we're only seeing part of it here, but it's still parabolic. So when it says maximum or minimum, that's a key word. Here you want to find the vertex, because the vertex always occurs at the max or the min, depending on if this thing is opening up or down. So remember, to find the vertex when we're in standard form, the x value, or in this case the t value, is opposite of b, which would be negative 16, over 2 times a. Well, the negatives cancel, so you get 16 over 32, which is just 1/2. Now remember though, that's the time, okay? So we're actually answering the second part of this question first. The time when the diver hits the maximum height occurs after just half a second, okay? Now, how are we going to get the actual height? We're going to take this 1/2 and we're going to plug into, so our vertex is 1/2 comma something. We're going to plug that 1/2 in. Now, you're going to want to use your calculator to help you out here. Remember, our equation was h equals negative 16, but we're replacing t with 1/2 squared plus 16 times 1/2. And then it was plus what on the end? 40, right? Okay. So I can do this in my head, but you can certainly use your calculator. That's fine. 1/2 squared is 1/4 times negative 16 is negative 4. Half of 16 is 8 plus 40. You're going to get 44. So remember, that's 44 feet. So the maximum height of 44 feet occurs, 44 feet is max height, and it occurs after just half a second. There you go. All right. So you have to give a little explanation here. So you have to show me that you know what you're talking about. You got to put units on here. All right. Now the solutions, remember the solutions are the x-intercepts. Okay, the x-intercepts. And it says, find the solutions and determine what the solutions mean in the context of this problem. Well, to find the x-intercepts, or in this case the t-intercepts, we replace h with 0. And we have what? Negative 16 t squared plus 16t plus 40. Now, there is a GCF here, but, you know, I'm looking at this and I'm thinking, I don't even want to mess with trying to factor. I am just going to do quadratic formula. And when you do quadratic formula, it's okay to leave this a value as negative. Okay? So remember, we're talking about x now. So opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2 times a. Now next step, negative 16 plus or minus. This denominator is going to be negative 32. Let's figure out what this thing underneath the square root comes out to be. I got my calculator here, and I'm doing that right now. And I got this huge number of 2816. Don't freak out about that. Okay, now remember, we use our calculator. We're going to do one with the plus and one with the minus. So I'm going to do negative 16 plus square root of 2816. I'm going to hit enter. I'm going to divide by negative 32. And I came up with negative 1.15. Actually, if I round correctly, it would be negative 1.16. That's seconds. And now I got to do the subtraction one. So negative 16 minus square root 2816, hit enter, divide by negative 32, and I get 2.16. Okay, now we found the solutions, but we're also asked to determine what do they mean in the context of this problem. So first of all, remember, t is time. This one we are going to cross off because we cannot go back in time. So the solution that's correct is 2.16 seconds. But what does it mean? What does it mean? What happens at 2.16 seconds? Remember, the solutions are when the y-intercept is 0. In this case, when h is 0. We set it equal to 0 right there. And what does that mean? At 2.16 seconds, the diver hits the water. Okay, that's what it means. All right. Okay, we're going to do one more in the back. Very similar. Instead of a diver, though, we're talking about a ball. Ball's being tossed, and its height can be represented in h feet after t seconds by the equation that's given. Okay. Now it says find the maximum height the ball attains and when does it occur? Remember, maximum height, that means find the vertex. So x, or in this case t, equals opposite b over 2 times a. Okay. Now that's negative 64 over negative 32, which comes out nicely. It comes out to just 2. Now we got to plug that 2 in, okay? And remember, this is time. This is when the maximum height occurs. Now let's plug that 2 in. Negative 16, replace the t with the 2, plus 64 times 2 plus 20. So that's going to be, 2 squared is 4. 4 times negative 16 is negative 64, plus 128 plus 20. And we come up with 84. So we have a vertex of 2, 84, and that means at 2 seconds, the ball gets to a maximum height of 84 feet. All right. Very similar to what we did in the previous problem. Whoops. Okay. Now this next one looks a little bit different. Look, it says, how much time does a ball spend above 45 feet? Well, we see here in part A that it got to a height of 84 feet. If you look at the equation, I didn't ask you in this one, but remember they have a starting height of 20. So it gets thrown upwards. So how much time does a ball spend above 45 feet? What are you being given here? That 45 is it's feet, so it is the height, right? So we're going to replace the h with 45. And remember, when you're going to do any solving, you want to be equal to 0. So you have to subtract 45 from each side. Now, if I subtract 45 from 20, that's going to become negative 25 there. And there's actually not even a GCF in this thing. So there is no way I'm doing anything other than thinking about quadratic formula. Negative 16, positive 64, negative 25. T equals opposite B plus or minus square root of B squared minus 4 times A times C. You're going to get some big numbers here, but that's why we have calculators. All over 2 times A. So that denominator becomes negative 32. Figure out what that number inside is. I'm doing it right now. 64 squared minus 4 times negative 16 times negative 25. I came up with 2496. And now I'm going to do both. I'm going to do one with the plus, one with the minus. So negative 64 plus square root of 2496 divided by negative 32. And I came up with 0.44 seconds. And now I'm going to do negative 64, minus square root 2496. I'm going to divide that by negative 32, and I come up with 3.56. So what you notice here is both of these answers are positive. Now the question says, how much time does a ball spend above 45 feet? Now, in the Zoom lesson, we're certainly going to talk about how you think your way through this. But here, I want you to realize the ball starts at 20 feet. If you look at that last number in the equation, it was 20 feet high. So when the ball's first thrown upwards, it takes 0.44 seconds for it to get above 45 feet. And then at 3.56 seconds, it's going below. Here, let me do a little sketch here, see if this makes sense. And it's going to be very crude. But let's say that this is 20 feet. And let's say this is 45 feet. That's kind of the magic one that we're talking about, right? That's what the question's asking. And let's say that this is 1, 2, 3, 4 seconds. So this is time, this is height. So remember, it's at time 0, it was at 20. And that's before the ball was released. It takes half a second for it to hit 45. So that means it's going to, go up there, and then it's going to come down at 3.56 seconds. So you see, that's about right there. So you got a parabola, something like this. Okay. So you see, it went above at 0.44. It came below at 3.56. So the amount of time spent above 45 feet is you would subtract these two. You would subtract these two, and you would get 3.12 seconds above 45 feet. Okay? Now you see here, the ball eventually is going to hit the ground. So now that's what question C is asking us. Replace h with 0, because that's the ground. Negative 16t squared plus 64t plus 20. Again, I'm just going to go quadratic formula. So t equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. Almost there. So t equals negative, sorry, that's the denominator. Just getting ahead of myself. So this number inside is 5376. So now let's do the plus and the minus. Negative 64 plus square root 5376 divided by negative 32. I get negative 0.291. Actually, I've just been telling you guys to round to the nearest hundredth typically. Now let's do the other one. Negative 64 minus square root of 5376 divided by negative 32, and I get 4.29. Now again, this is time, so this first answer makes no sense. We cannot go back in time. The ball will hit the ground after 4.29 seconds, and that makes sense with my graph. If you keep on extending that parabola, it's going to be a little bit past the 4. So it looks like I did a pretty good job with that. Again, that was somewhat quick, a lot of information to take in, a lot of tougher stuff with the word problems, for sure. But remember, live Zoom lessons, so you can ask questions. Hope to see you then.